Yeah. So hi everyone. You're welcome to should I say the second meeting of Ansible Toronto. Um, we we should I say we kicked it off a couple of weeks ago after about 3 years, and yeah, so it's still early days yet. So last week we had, or should I say, in the first meeting we spoke. We had someone from Consensus Ventures speaking about how they use Ansible for image management and for image testing, and um, so this week we'll be moving on to using Ansible um, as a tool for network automation. Um, yeah, of course, I realize that in the world of DevOps, not everyone has a networks background, but Ansible is a flexible configuration management tool, which is used not just for servers and applications, but is also used for network devices. And that's why we have Mark here with us to run us through how Ansible is used from his own perspective. Thank you all for joining in, and the meeting will be recorded. Hopefully, we'll be setting up a YouTube page where the recordings will be posted. Okay, let me allow to share. Sorry, Mark, can you share or can you speak? Is it? I know I have to give you permission to do that. Host tools. Okay, so you're not able to mute. Okay, yeah, so you should be able to mute.
There we go. Seems to be working now.
Yeah, okay. Sorry about that.
That's okay. Don't worry about it.
Yeah,
It's the better way to do it is to have
yeah,
collective permissions. Yeah.
okay.
All right, let's get started. Let's see if I can share my screen. Oh, I was gonna send a request for sharing. Still need to do that.
Yes, all right.
There we go. See if I can share the screen. Oh, sorry. A little bit of Mac difficulties need to allow it to do it. 1 second. There we go.
That's fine.
Try again. There we go. Just confirm you all can see that.
Yes, yes, we can.
Perfect. Okay, so the presentation I would like to give today is basically an overview about network automation with Ansible. The context of today's presentation is something that I don't often see in the context of presentations. Oh, let's just get rid of this. Which is every time I've seen like workshops or presentation on Ansible, someone immediately goes into a demonstration, which is like the lowest common denominator, which is doesn't matter what vendor platform is, I'm going to deploy some VLANs or I'm going to do some show commands or like get some operational state from the devices. But I personally don't think that that's really the hard part of working with Ansible or any type of automation with networking systems. The other time I see presentations, it really comes to some of the stuff I'll deal with later, which is more of the advanced stuff, which is actually using Ansible as an abstraction for complicated imperative programming for Python. But I'll come back to that later. And of course, my thing's not working now. There we go. So a little bit about me. I have about 15 years in the industry. Next year, I'll have that. And given the average age of a network engineer, that means I have no experience. Basically, I'm basically like my first year in the industry compared to like some people have 40 years experience. Some people have been doing this since the 80s, right? I like to pride myself as a Linux and systems thinking enthusiast. That's why I branch a little bit more onto the Ansible side of systems administration side. I like to think of the network as part of a more holistic system. When we think about Ansible, it's really good on the server side, really good on the DevOps side. But if we think about it more as like we should be able to instantiate a service end to end from the application to the network. That includes firewalls, fabrics, and everything like that. Recently, especially at my previous role, I was really focused more on network automation. I've been a big member of the Network Automation Forum. This is a new group that basically started about 2023, which has a forum and a conference that's a sister conference to it called AutoCon. I'll be speaking at that next month in Austin, Texas. I'll be talking about platforms and stuff like that, which is very relevant to things like Ansible Automation Platform. I'm also the founder of TORNOG, which stands for Toronto Networks Operators Group. It's a network group specifically for networking related functions. But of course, systems administrators, DevOps, developers, everyone is welcome as long as you want to know more about networks and how they function, especially speaking with, in a very neutral and friendly place, network operators, architects, and network developers. In my current role, that I've been doing for about 2 months, I kind of stopped counting the days. Every day is a crazy day. I'm a consulting engineer at Nokia. So what I do day to day is I meet with clients, new and old or potential, and try to speak with our solutions and how they fit in with what they're trying to achieve in their infrastructure. So I travel all around, but I'm really focused on the Canadian market at this moment. Speaking a little bit more about Tornog, very, very soon, about 3 weeks from yesterday, I believe, we have our second meetup ever, which is in the fall, November 12th. The QR code here will get you a ticket. It's free. Based on the response I've been getting so far, it looks like we're going to have a halal diet. So we'll probably have like maybe catering from Alibaba. It'll be a great conversation. We'll have two presentations, and they're going to be announced on Monday. Right now, a sneak peek, it looks like we're going to be talking about AI in terms of networking, like developing trends and how to deal with this automation portion, as well as quantum networking, which is a big other thing that everyone's worried about over the next 5 to 10 years. So please do join us. It's free. We have lots of space. We expanded it from the last time, and it's downtown Spadina Center for Social Innovation. So this presentation, we only have about 30 minutes today, and based on some of these topics, we could go for hours and hours and hours and hours and hours and do workshops. So really my idea today, is, especially as a network expert, is to take you from unknown unknowns to known unknowns, saying like, I now know that these exist, which is a great starting point. I wish I could kind of hit the books and understand a little bit more about that, right? So luckily, there is a way to do that, which is there's a brand new book that just hit the market from my friend and colleague, Christian Adele. We never actually professionally worked together, but we know each other from the Network Automation Forum. He just released this book, and it really talks about like how to go from zero to hero with Ansible using tools like Nautobot because he came from network to code and various other functions. It'll use tools from Cisco like PyATS. It's very vendor neutral. It's going to hit everybody's use cases. I really recommend it. But if you say, hey, I'm a man or a woman of the future or of the present day, reading is for nerds. So you might want to say that, like, well, maybe in the future, there might be an event coming up soon for Toronto Network Operators Group, or maybe something for the Ansible community group where we can, Olu and I can maybe get a workshop going where we can kind of get you more hands-on with some of these functions, right? Now, we probably want to do more of a half-day function for that. But if you're interested in that, let Olu or myself know. And as I gave you the QR code previously, which is for my LinkedIn contact. So when you think about like automating networks, when we think about how we're so far ahead on the compute side, the storage side, automation, like, and the network people seem to be over in the corner by themselves. And I have a little slide for that as well. And I imagine most of the audience today is not really a network architect. So why is it so important? It's because basically it's the critical infrastructure that underlies everything that we do. And this little meme here is kind of showing that, like, when the network goes down, we all kind of go down. In fact, we just experienced that the other day when the US East region of AWS went down. It wasn't exactly the fabric that went down, like the infrastructure, the network switches and firewalls. It was actually DNS. And we have a saying as network engineers, which kind of annoys people in the development and the DevOps space, saying it's never the network, but if it was, it's DNS kind of thing. And that we just proved that recently this week. And because of this kind of rough approach that network engineers take, this is what a day in the life of a network engineer looks like. So when someone says to you, oh, great, welcome to the team. What are you doing for us? Well, I'm a network engineer. It's like immediately annoyed because you think about all these amazing cohesive kumbaya processes you have on the DevOps side, and the networks over here, it looks like they're running like, spaghetti code in their domain specific languages in a CLI terminal, or it might be even jacked into the box sometimes, right? So with tools like Ansible and DevOps and infrastructure as code, we try to bring that to the future and then make this a cohesive system together. So my pitch as to why you should consider Ansible, despite all the other frameworks that are out there, including Terraform, which is under Broadcom and such now, is to think about like, look at this mountain of, I was recently moving apartments and I'm now finally in my little home office. And I asked my wife to take a photo of all these textbooks I had to move over for my lightning talk I'm going to do at Nanog in Texas next week and say that like, we as network engineers have to consume so much context. Every system has its own domain specific language. All these protocols have such a wide domain. So somebody could spend 10, 20, 30, even a whole life to really understand some of these contexts. And then you expect a brand new engineer or computer science graduate to come into the field and just absorb this context overnight. That's why this system becomes such a niche silo over by itself. But the beautiful thing about Ansible is that you can basically abstract that away in a very readable markup language, which is YAML, and basically make operations as code. You can take all of that complex business logic and all that complex imperative, put that all in Python, codify that, and then make your business intent done in YAML that everyone can share around. So you have a new operator or a seasoned architect. They're both reading at what is the intent of this system. And it's easy to say that's right or that's wrong before we deploy it to production, especially when we're going to deploy to production on a Friday, which nobody does, right? So the main thing I think that really hangs up people when you're coming, like you went and you said, look, oh yeah, I have Kubernetes. I've mastered it with Ansible. Oh, I have like OpenStack. I've mastered it with Ansible. I've got like storage. I got VMware. Everything's mastered with Ansible. And then like, I understand REST. I understand like open API schemas. No problem at all. And then you say, what is going on over here in the network world with these APIs? So when it looks at Ansible, the main feature that's the lowest common denominator across Linux systems, across networking systems, SSH essentially, Secure Shell essentially is an API. Every single network operating system provides SSH as an interface. Unless it's ancient, it could be Telnet. It's a whole different story. You could probably abstract that away using other systems. And Ansible has strong feature-first support for this Paramico. And Peter Spragata used to be an Ansible architect once upon a time. Now he works at Atential. He made some great work to bring this into the common libraries in Ansible. The other thing about SSH is that we understand it very well with the many skills of the many people to work with it. Everybody uses SSH every day as an IT engineer. So it provides easy to work with encryption in terms of the key exchange. The connection methods are understood. We all have our favorite clients. It's a solved problem. And it's simplest to implement in terms of when you look at the common modules and the libraries that come with Ansible. However, it has, with being the lowest combination, of course, it also has the biggest trade-offs. All the text you're going to get from a network operating system, it's all going to come back to you as a garbage of text that you can print as in a debug command. But when you try to actually apply logic to it, saying, well, if this variable is in here, you're going to have a spaghetti of words coming from this network operating system. So it's hard to create logic around that. It also requires that domain knowledge. What is the right show command? What's the right show command in this instance? What is the order of operations to configure this to say like configure terminal, paste in a bunch of configuration, and those order of operations sometimes matter. It's not quite like in Linux systems, like in terms of declaring via Docker Compose a system to come up. So it gets very complicated very quick. Yeah, so there's no procedural or programmatic way for configuration using this interface. Uh, so, and the structure of texts are also at the mercy of the vendor. So Cisco might have roughly the same output for 20 years, but it's basically underlying C functions that just do printf statements. They can move a column around anytime you want. So even if you are doing some kind of regular expressions or parsing, which I'll get to later, they can move things around and completely break anything. There's no guarantee that this is meant to be an automation. In fact, a colleague of mine, the CTO of IP networks for Nokia, he says that like it can SSH is an API that can be abused for automation if you choose to. It's really meant as a human presentation layer. The next thing you're going to find a commonality between all the other APIs. There's this thing called Yang. So I want to give you a little information about Yang. Essentially what it is, and it's kind of confusing, it's a data modeling language for communicating with network devices. It's sometimes also referred to as a schema definition language, and you'll see why in the example I have after. It's built like XML, almost one-to-one by XML. Clearly, people that invented it loved XML, but it's not XML. So that also makes it confusing. We don't have the tooling that we have in XML, which is a solved problem a long time ago, into Yang. Uh, the model coverage is also really hard because you have a neutral space called OpenConfig that provides the models that are implemented using the schema definition language from Yang into the actual models that define these functions. But there's also the IETF models, which are not really used. And then the vendors themselves bring the models that are specific to their exact functions because not every vendor's system, like the hardware and the chassis, looks different. And how could someone create one that's a standard when the electrical engineering is not standardized or the actual like layout of chassis is different based on different vendors and the markets that they operate in? Uh, Although, even that being said, it's still a structured text. It's a proper API. It provides a lot of like serious functions in terms of remote procedure calls. It's just not as elegant as the query languages that we expect, like Elastic, SQL, anything like that, or the tooling and ecosystem that we get with Open API schema. Like when you look at a system for Yang, like there's no like Swagger UI to give you inline documentation for a platform. No, you have to go to a vendor's website and just start like control Fing for things. It's crazy in this environment. And that's why I feel that network automation really didn't take off. It's because the tooling and the insight wasn't really there. This is kind of what Yang looks like in terms of the overall design of it. As you can see, just like any other schema, it actually defines what the type should be. Should it be an enumeration? Should it be a U integer 16? Should it be a string and such like that? And it gives you all the options. And on the right-hand side, you can see something that's from OpenConfig, the actual implementation of that. So the container, the list of interfaces below it, and then the least, which is basically, that means an object in Yang. So you can see in this case, like the name of this interface is a string, of course, and then the admin status is a numeration, which means it could be up or down. But when you look at the bottom, they basically took probably the most hated thing from XML, which is XML XPath. And they implemented that as the actual way to get state from the devices. So you can see they even took that name equals gig eth 00, and that's basically a namespace in XML, the thing that people hated the most. In fact, I have this textbook here, which I got at Value Village for about $4. It says XML in a nutshell. You know when this was published? 2001. Somebody who was born in 2004 is 21 these days. Like this stuff is way behind us in the rest of the DevOps space. So we're finding that we have to suddenly go back in time to operate with these so-called bleeding edge, cutting edge systems. Luckily, there are some new tools and developments that are bringing these into the future. I'll come to that later. This is going to be probably when you're talking about Yang, this is this is really the golden child of people actually getting things done in production. So the tool, the API is called netconf. It obviously stands for network configuration as an API. So it utilizes SSH for transport. So great, easy to implement, understood. Our firewalls probably already allow it. It uses XML for encoding. Not so great if you're like, modern and you love JSON. And it has the Yang for underlying the underlying models. It's a standardized thing, which means giant telcos love it, governments love it, everybody can use it. There's no controversy, and I'll come back to that. The controversy is later. It's fairly widely supported across many vendors and networks. Juniper, Cisco, Nokia, everybody supports NetConf in one way or another. The problem as well is when you start to doing high scale of operation, XML has just a bunch of nested information just to change a 0 to a 1 or to change a string is just a massive garbage amount of text, which makes you do all the processing for that text on your side. The good thing though is Ansible has pretty rich support for it, specifically in the net common library. So it's very easy to implement. There's so many examples on the internet. So it's a good way to get started when you want to go from text parsing to this. The next one is the one that seems like the thing that would have saved the industry, but actually was kind of a bad idea in hindsight. So it's RESTconf. So basically, it's taking that same concept of netconf and bringing it into the REST domain. So it uses HTTP as for transport. It utilizes XML or JSON for encoding, just like any other web interface can. It's also standardized, so it's great. The problem is no one really ran away with this except for Arista and one department of Cisco kind of ran away with this. It's not really widely. So if you say, oh, I'm going to go all in on RESTconf because this one device supports it, then you'll still have like so many different levels of tech debt on the other side of your domains, and you're going to be writing so many different domains of scopes in terms of your operations. So that's something I would be concerned about if you were to say RESTCONF's going to save the day, unless you're feature complete stacked up to the one vendor that supports it feature first. It also has a similar overhead. You're still sending a bunch of text just to change one string inline. Uh, the the benefit though is that basically it's just APIs, the REST APIs. So there's great support in Ansible via JSON modules in the libraries, as well as a URI module, which is basically similar to like the REST API that you could expect in Python. It's really easy to work with. So many people understand it. The documentation is pretty good behind it. The next one is a little more niche, but it's pretty powerful compared to the one I'm going to show you after. So it's called JSON RPC. It's basically like RPC stands for remote procedure call. It's lightweight, stateless. It's more common in like a systems and DevOps space. You might already have developers that already work with it. They have great workflows. You can just implement this for your network systems. So, but the only problem is that only cloud native vendors are really pushing the forward future of networking, which is Nokia and Arista really support this. Arista supports it via their eAPI. Nokia has it basically native in our SR Linux, basically our cloud ready, our DC ready platform. It's definitely not standardized in the network ecosystem. It wasn't even meant for networks to begin with. So why would a vendor really say this is the right way to implement it? That's like eAPI for Arista, and we do it a different way at Nokia. And it relies pretty heavily on the vendors on our side to implement the collections because JSON RPC is even a little niche for Ansible, and we do at Nokia, and so does Arista. We do have great feature support for it. It's just you do rely on us as a throat to choke to help you out with that. GNMI is the new kid on the block. It's the cool kid, right? And we have vendors love to say the G stands for, okay, not gold mine, not gravy train, gRPC. And the gRPC, or the the G actually stands for gRPC. So basically, it's gRPC Network Management Interface. gRPC is basically Google's remote procedure call. They basically built it feature bespoke for their cloud, and they said, "Hey, why are we managing these systems over here using gRPC and protobufs, and these network systems we have to use like text scraping?" So they went and implemented an actual API for network systems, and they just gifted it to the industry. It's not really standardized, which is the kind of controversial point. Like for example, giant telcos refuse to touch it because they know that Google has a huge habit of killing project that they introduce to the industry. It's very lightweight and powerful because it uses HTTP2 for transport and also has protobuf, which basically you're actually sending text to and from in binary. So it's very small, and you can encode it in whatever or serialize it whatever you want. You can use XML, you can use JSON, no problem at all. Whatever you can use prototext, which is another feature first element for them. Uh, it also has feature powerful functions such as streaming telemetry, which means we take like the very CPU intensive and ancient thing called SNMP, and we could basically sample in real time the state from devices. We can send like those small payloads to do huge levels of configuration to network devices. We can also subscribe like a pub sub model where we say, when this state changes on the device, please let me know so I can do something about that. So when you think about SSH, which in reality you'll probably come back to as your lowest common denominator, you'll probably end up messing with it. What I would say is that there's two libraries that are going to get you a little bit farther because when you take that unstructured text, what you really want to do is transform it into structured text. Instead of writing your own regular expressions in Python and abstracting that in, there's two feature-rich libraries that are already available for you. So this one is from Cisco. It's Genie. It's not really open source, but it's free as in beer. It's available. So it takes unstructured text and basically it turns them into a list of nested dictionaries. So basically it takes them and makes them into dictionaries. So it's really easy to work with, and it's not super easy, but it's definitely pretty easy to work with in terms of Ansible. It relies heavily, they're basically writing all that complex regular expressions for you underneath, and then they're basically bringing it to the community. It's meant to be usually worked with Python, but Ansible is definitely able to use it. There's a repository that's out there. You can definitely go and look at it. It's not really maintained. I haven't really seen a commit to it in 6 years, but it still works to date. It's no problem, and the code is available. You can do whatever you want with it. It also has a high coverage of support for parsers. So this is from their documentation page. I looked at it. They have a lot of operational commands available to pull the state from devices and do your pre and post checks. And they even support Nokia's SROS, for example. But Arista, anybody to be considered a competitor to Cisco, they were not shy about making sure that this is the tool that's going to bring net DevOps into the future. I think we just kind of moved on a little bit from there. This is kind of what it looks like. I don't have a lot of Ansible examples because I think diving in yourself is the best way to go. But basically showing us that it's not so overwhelming to introduce this. The problem is you basically have to maintain this as a Python module, import it, but their documentation helps you run through that. Another option for SSH, which I think is the most flexible one, is also something that Google used to use before they invented GNMI. And it's something called TextFSM. It's fully open source. It's a parsing language that basically it makes regular expressions easier. You can define in a TextFSM file, very simple and easy to read regular expressions to be able to give you structured JSON output. There's a strong library of community written parsers. I'll give you a link to that in a moment. And it's fully integrated into Ansible NetCommon, which means Peter Sbrigata and the Ansible team saw this as a powerful tool, so they made sure they gave first level support within Ansible so that you could basically just do an Ansible parser. This is the one I was referring to, the community. Basically, this is maintained by the Network to Code community. They have so many great operational parsers for many, many, many systems, and a lot of systems are built off of this. And of course, I know I'm giving you a lot of QR codes. This session is being recorded, so feel free to come after. And if you want the slides, reach out to me on LinkedIn. I don't mind sending them to you. This is what it looks like. Basically, you can say like refer to the parser that you want to get, send the command that you want, and it's going to give it to you. And you can see in the comments below what that structure would look like, right? So it's a very simple JSON output. So not shilling, not sponsored, because the next tool that from Nokia is actually open source, and we actually gifted it to the open config industry, which would implement basically data models and open ways of working with network systems. It's something called GNMIC. It's basically a CLI tool, a binary written in Go that can be used to work with GNMI and Yang objects. Basically, it allows you to read from a device all the capable functions it has, give you all the XPath, make it so much simpler for you to manage that system instead of going and looking at the vendor documentation. It's kind of like doing an SNMP walk in the SNMP land. You can also use this tool to fetch from the device for you and give it back, and it can export it to any system that you want. You can just export it to Prometheus. You can export to NATS, Kafka, whatever you want, right? You could send it somewhere else, like if you could give it into Ansible automation platform, right? The other thing as well, it allows you to do that pub sub that I was talking as well, where you can subscribe to a particular object and say, hey, for example, when this critical interface goes down, let me know because I want to do something. So you can basically take GNMIC, pair it with something like NATS or Kafka, a messaging bus, and then send that to event-driven Ansible to say that when this thing happens, I want to kick off a workflow in my Ansible automation platform to go and remediate that problem. So it's very powerful and it's very real time and it's bringing network operations in the future instead of making it more reactive like it was in the past. So take a look at it. Like we said, we gifted OpenConfig. It's free, open source. Go away with it and see, and maybe I can come back at one point and do maybe just a 30-minute session on that use case I was talking about, which is getting an event from the network, sending it to event-driven Ansible to kick off something in Ansible automation platform. I think that'd be something if Olu has time in the future. So the really powerful tools that I might go for with networking to managing your network with Ansible, these are things where when you get started with Ansible, and that's why I hate a lot of these workshops, they say just deploy VLANs because things get so much more complicated when you think of the vast system of a network and all the operations that are going on. Number one, which is that it's okay when you're basically making these Jinja templates to go ahead and make a bunch of VLANs or whatever. But when you start to do complex level systems and saying, I want to get all this operational state from all these devices, you end up making these massive, massive, massive workbooks that's taking so long to execute. There's a better way to do this. There's a tool that's basically the industry standard for what people call the source of truth. I don't think there's anything such thing as a source of truth, but it's definitely it's a data modeling tool, which allows you to say, this is what my network system is. These are the services that rely to this interface. This interface is the speed, all the information, you put that up front, and it actually has Jinja 2 rendering in defined modules. And because of there's a fully featured Ansible collection, which what this QR code is for, you can basically pull that Jinja information and then render your configuration to send it to devices. It's so much more slick that way. It's also open source and extensible. You can create your own modules. It's written in Django. It's something that basically the industry is building so many tools on, and Ansible and NetBox work really well together. There's also a competing tool called InfraHub. But it's little early days in terms of what the ecosystem is out there in terms of the community. The other thing as well, just to show that this is more of a neutral element, is that when you think about actually doing Ansible, and some people say like Ansible, the problem is maybe once you start working at large scale networks, it doesn't scale very well. And the reason why it scales so well on the compute side, and it doesn't seem to scale very well on the network side, is because what we find is a lot of the community modules out there, what they're doing is they're basically doing imperative Ansible, which says do this and then do this, and then check this, and then do this, which is focusing on how to do things. And then the Python underneath is doing those imperatives. So it's basically a double stack of like overhead that you're trying to do. Um, Instead of a declarative mindset which I think where Ansible is so powerful. When you look at the compute side, you think about how you're going to instantiate a container or a service. You say, I want HTTPD, I want it to be this version, and I want it to be up after I enable it, or I want it to have this config file. You're just declaring what you want the outcomes. You don't care if it's a container. You don't care if you have to SSH in, if you're using another API. All that stuff is abstracted away imperatively via Python, and Ansible is more a powerful declarative so everybody can read what is the intent of this action, essentially. So this tool called Arista's AVD, which I think stands for Architect, Validate, and Deploy, if you have Arista systems, it's fully written in Ansible. And it basically says we're going to handle all the pre-check validation, all the declarative intents to basically generate all your configuration, deploy it to the network within like seconds, if not minutes, as opposed to hours sometimes. Um, and basically do all the what is the intended outcome of the system. And what the great thing about this, even if you don't have Arista, you can go and look at their things because it's open source and say, that's how you do Ansible for networks. That's how you do declarative. I think Arista and Nokia are really pushing the boundaries of getting the future of networking out there, right? And so basically, this is feature rich for your CI/CD pipeline, and it's 100% Ansible. It also can manage their platform, which is CloudVision, to give a little bit more of that secret sauce. The other alternative is Nokia's EDA, which is confusing because Ansible has event-driven Ansible, and we have event-driven automation, but event-driven Ansible and event-driven automation could actually work together. So you have a double EDA squared. You could call that SAC if you want it, right? But basically, it's a platform that's feature-rich, bringing these declarative, intent-driven, and built to scale. It's built on Kubernetes. It's extremely extensible. It's multi-vendor. It's going to work with Cisco. It's going to work with Arista in the future. Like it can work with Sonic today. Like it has an ecosystem for working with VMware, for working with OpenStack, with working with OpenShift, right? Like it's going to work with everything. Basically, it really helps you bring your network. And of course, there's a full Ansible collection for managing this platform. On the EDA site, I sent you here to the documentation for the Ansible collection. But if you look at the EDA site, you can say how to try EDA. But of course, the SR Linux itself, I'm going to come to later, which is our underlying operating system that it manages, has rich Ansible support as well. So it's fast, highly scalable, extensive, and it also provides a function that AVD is not going to provide you, which is a native digital twin, which says my intention is that the network's going to look like this after. It's going to spin up a virtualized version of that network and say, if I apply this, what will be the outcome? So it's going to do inline data modeling within seconds for you, right? So this is the stuff that's really, really, really hard to do when you're building it, like, do it yourself in Ansible, because then you say, how do I truly do this declaratively and do all these checks in the systems? It's definitely possible, depending on the maturity of your team. But this kind of helps you get you further, kind of thing. So that's maybe another way. But if you think about like platforms in general, every network in the future, and I'll come back to every network vendor has a platform from the system. So that's gonna be my closing thought at the end there. So one thing I would say is give it a try for yourself. Like if you want to just get started and do a real workshop, Nokia's SR Linux, we have this is like an open and easy to get. We also have an open source tool called Container Lab. You can just pull this straight from Docker Hub and get our operating system and go through this tutorial, which is basically saying, how do I work with this? Now, this example uses JSON RPC that I was referring to earlier, but it's a really, really decent tutorial to get you through and start saying, how do we do this in a modern way of working with essentially cloud native network operating systems and stop thinking about the conf paste a bunch of config and commit and hope for the best kind of thing. It's a little bit more modern in that way. But my closing thought is that kind of what I said here is you need to think about do an analysis in your network and think about what APIs do I have in my network? Do if the only thing I have a commonality between them is SSH, the honest truth is that that's probably where you're going to have to go towards. The other alternative is say, hey, if I have 40 Manager and I have Nokia EDA, and I have Cisco's DNA Center for my campus and stuff like that. Why don't you say Ansible use the URI module and then let those tools abstract away all the hard parts for you and make Ansible as a workflow in Ansible automation platform and say I'm going to instantiate the WAN in Nokia EDA and the DC and the DC gateway. And then in the LAN where the user is going to connect, I'm going to instantiate that connection to that service. And then for manager, I'm going to secure that and make that overlay, like that SD-WAN play or something like that, right? So let Ansible operate those things for you. That's the way really to scale networking. And if you find that you want to do it yourself, it's definitely possible. But think about those things that those platforms are solving for you and do that analysis. But if I had to say what is the way truly to go forward, it's to keep giving feedback to network operating vendors and say, I need this API to be more mature because when I actually try to use your data models, it didn't actually work so well. So feedback and collaboration and coming to places like Tornog and also be at the North American Network Operators Group next week, I also mentioned, come to places like that and say, we developers deserve better. We want infrastructure as code. We don't we want, operations as code. That's what we want. But yeah, that's kind of my closing thought on that, and love to open up for questions and talk after that.
Thanks a lot, Mark. We it's not your usual tutorial where you dive in straight to VS Code and start coding. I'm sure there are a million YouTube videos for that, but it helps to kind of understand the thinking behind how we came to from the world of Yang and NetConf to where we are right now. So if you have any questions, please feel free to put them in the chat. Yeah. So I think the first comment I'll make is container lab. So if you're thinking of starting off with starting off with network automation, a good spot to, well, full disclosure, I used to work with uh, the company that preceded Nokia back in the day. That's where Mark works. I used to work with Arcata back in the day. So, but Container Lab is a good tool to start with. You can we don't have to go back to the days of tools like GNS3, where you have to have some sort of high power CPU to just bring up a few routers or thereabout. But you can just download Container Lab and then um, spin up a few images. It's user friendly with the YAML format. Yeah. So I think there's a comment. What are customers doing? Sorry, Mark. I think there's
Yeah,
a
okay,
question
yeah.
in
So
the chat.
I'll just come back to that container lab before I get to the question.
Yeah.
But the main thing about container lab is that what it really brings to the future is that we support all the vendors, whoever has a container, or you can use the project called VRNet Lab. So if you have existing VMs for your network vendors, we can basically turn those into containers. They'll still be a little slow like the VMs compared to the containers, but it's still possible to integrate that. The other benefit is you can basically say you have YAML to define what your lab is, and you can also bring your applications, as such as like your Ansible automation platform and Grafana or whatever else into the lab because you're basically just connecting these containers together. So you can say, I'm going to build my infrastructure as code or lab as code, as we like to call it. Put it all into Git and share it with your whole team, and they can run it on their laptop or on the compute on their side. So that's a nice thing about it. So the question that Sandev is, what are customers doing for their existing on-prem environments using Ansible as infrastructure as code? So I went to the Ansible days that were in Toronto recently, and I saw some great presentations. So what I find is that what most people are trying to do, because once again, like Ansible is really great as an abstraction tool to define what is the outcome I'm trying to do. So basically, companies like RBC and I think Shared Services Canada also did a presentation there. They're basically saying that I'm trying to define a catalog of services that people can deploy by requesting it in ServiceNow. So basically what people are doing is they're using things like ServiceNow or other competitors to it, like Jira, Atlassian Jira, and saying like, you can request this service. I'll send it to the Ansible automation platform, and I'll basically instantiate a workflow which delivers the service for you immediately. But once again, what I found is that it wasn't just taking and saying like do this show command, paste this thing, get the configuration here. They were actually writing all the complex stuff in Python and then using Ansible as that abstraction, that readable portion of a workflow. So they were really writing the stuff in Python and then saying use the Ansible native module to bring that into Ansible. So I think that's a really complex thing that people are doing at scale. And at more of a like a smaller shops element, a lot of them are really going to kind of whatever's available out there in the community, like using some of the tools I mentioned, as well as some of the native things within like the Cisco Ansible collection or the Arista or Juniper Ansible collection, and basically saying, I'm deploying this VLAN over and over and over and over and over. I just want to be able to get rid of that and just move on to funner things. So I see a lot of that. Uh, so the question, next question, I hope that answered your question, Sandiv. Albert Tech says here, my team uses Terraform to deal with all the intra, including networks. I think it means
Infra.
infra. Yeah,
Yeah.
I use Ansible to config app, etc. I can never tell where we can use Ansible for networking. Can you talk about that? So exactly that. I would say that like when it comes to like Ansible is something where you can say like you could even probably give it to someone in change management and say, look at this. This is the intended outcome of what I'm trying to do. I'm going to enable this service. I'm going to enable it in this region, and I'm going to do these checks after in my workflow. They can look at that and say that's the intent. That's like your method of procedure that they can really read a lot faster than the text files we used to use before. So it's kind of like a service intent. And of course, because it's infrastructure as code, you can run that in a pre-prod environment and say, I tested this. So I'm going to use Ansible Automation Platform or another scheduling tool like Attentional, I guess, I suppose, to schedule this off hours during the window. And this is how I'm going to validate that that change is correct. So I think that's to say is like basically saying that like you're giving your operations as code, but in a readable way for the executives as well as the people who really keep the place running, such as change management or change control or whatever. That's a useful way to use it. But as well as just generally saying that like it's easy for network engineers to work with you collaboratively to say this is how we're trying to codify the operations, that mountain of textbooks. And it's easy for them to get going with Ansible quickly and operate with you for you writing the low-level code in the systems, and then basically saying that we together are defining how to enable the service to allow the developers and the systems administrators to enable services within the network. So really, it's just about like operationalizing something that was very niche and opaque over here and bringing it into the rest of the infrastructure as code elements. So I think you should look at it from that way, which is Ansible is a powerful domain-specific language that was built for humans. Like the people who wrote Ansible were Python experts. They wrote Ansible because they're lazy, smart developers. That's what they were. And they said, I want this for me. I want this for you. I want this for your grandma. I want it for everybody. So I think about it that way in my perspective. Okay. So the problem with Terraform is that basically Terraform by default is extremely declarative and like dry run heavy. So what it does is that when you just take Terraform and you point it at a network API, some of these network operating systems, some of the modern ones like SR Linux and like EOS and stuff that were built for this, Terraform is very read heavy. It was meant to go to cloud platforms and say, I'm going to check, 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 I'm going to check. What we found in the networking world is you point that at an old Cisco router, the thing blows up. It just goes offline. It wasn't meant for these print functions from C to really just be printed over and over and over and over and serialize that. Like the SSH daemon might fall down if that's your best case scenario. So with Terraform, what I would say Terraform is feature rich for platforms like EDA, the EDA from Nokia for your instantiating your cloud networking in Azure and stuff like that, as well as anything that the Terraform is feature rich for working with REST APIs and basically doing that validation of this is what I declare the outcome will be, doing a dry run and really declarative operations. Yeah. But yes, Terraform is extremely read heavy. Be very careful that your system might do it. We have an open source platform. My colleague Wim, the CTO of Nokia IP Networks, is working on called KubeNet, and he's trying to solve that by adding a cache layer in to basically protect the systems, the underlying fabric from those reads without having to have immediately a platform with the clicks and clicks. Because the problem with platforms too is that there is a trade-off. We went from really easy to type query language that network engineers, and we changed it and said that the mouse is now the king of the castle. The click, 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 enter forms. There's a trade-off. That makes we made our interaction with the systems declarative, but we made our operations even more imperative than it was before, saying I had to do this, and then this, and then this, and then press save, and then, click the thing again and see the status. That kind of sucks. So Terraform makes that easier for you by working with those platforms, right? So KubeNet, EDA, I think Terraform is the way to go in terms of operating the platform. So be the puppet master of the platforms, like Puppet back in the day. How do you argue for Ansible if you can't get outbound before execution? Hmm. So it's kind of a tough thing. So what I would say is that's where things like GNMIC would help you with that, because what GNMIC, I didn't mention it earlier, but GNMIC actually, what it can do, it can handle via GNMI pulling all that state from the devices, and you can put it in something like Prometheus, and then you can actually safely query that Prometheus database all you want using Ansible and get the state from being collected in real time via GNMIC, as well as GNMIC provides a feature-rich REST API. So you can say, instead of just, you know, executing against this device, you can say, well, getting the information from GNMIC and modeling it using something like Netbox, this is what I expect to happen. You can also basically do basically, like, basically using Container Lab, building your own digital twin, saying, I'm going to execute safely in a virtual environment against this virtualized SR Linux before I push it to production. Yes, I do have a link for GNMIC. I had it in one of the QR codes, but let me just get back here for you. It's just
So
gnmic.openconfig.dev. Yeah.
yeah, okay. So just to help a little there, so there are two things. So just like you mentioned, state is often a defining factor between the choice of Ansible and Terraform. So that's understanding how they handle state. And for some scenarios, Ansible has info modules like that, where you can actually like grab, depending on the collection or the namespace you're dealing with, you can actually grab through an info module. It could be, you can grab like the state for that particular scenario before you then run your operation. So in that case, you can, using an info type of model, you can grab the state and you can then use Ginger or thereabout, or
Yeah.
use to bring out the dictionaries and to know if, for example, if this is enabled, and then take these actions. But so it might not be all scenarios, but the thing from my experience in networking, sometimes you just want to get things done. Uh, not everything where state is not as important. Ansible plays in very well, and Ansible is also able to, because it's idempotent in nature. If it's fine, if the state is fine, it's not going to touch anything, right? So
Yeah,
it's going to,
exactly. Yeah.
yeah,
Idempotency is the main thing. If you build your modules, if yourself, make sure that you build idempotency in it, which is saying that, like, I'm only going to change if it's necessary. So network operating systems feature basically kind of a slight version of version control, where you could say, if I were to commit this configuration, what is the diff that I would get, right? So basically, you can do a show compare in Juniper. It's a similar thing in iOS XR. Of course, Nokia and Arista support that as well. So you can basically say, send that as your first operation, and basically what you modeled out in Ginger, or however you created your intended final state, compare that versus what the system will tell you to do, and that's how you kind of do your your dry run operations. And only, for example, if there was a diff, that's the only time you would actually make a change. And that's how Ansible makes it feature-rich, idempotent, right? So consider that. But yes, you still are sending a payload to the device. So consider how you're sending that payload, right? If it's a huge, huge, huge XML block and that device was already on its heels because it's a switch you should have upgraded 5 years ago and you didn't, and you ignored the CVE, maybe you'll kick it over, right? But yes, you're still sending it out. And that's why I think a caching element or using a platform maybe is the way to separate that concern of touching the network directly, because the network, as we originally said, is so critical, right?
Yeah, I think yeah, we hit 1 o'clock. Um, so first, I would like to thank Mark for hopping in. I met him at a Grafana meetup in Toronto, and then
Yeah.
he kindly agreed to come on today. We deeply appreciate that, and thank you all for sorry.
I was gonna say, like, feel free, like now that we've got
Yeah,
an intro, let's do another
intro.
session in
Yeah,
the future and let's get
yeah,
right
sure.
into VS Code and go
Yeah,
through all these scenarios,
all
right?
definitely. So thank you all for joining in. If you have any examples of talks, I mean, our only requirement is that it be Ansible focused. Please reach out to me on LinkedIn or through the Meetup group. I'm trying to speak to someone who works for a storage company to see if they can help with the next meetup. We would reach out to us by email if that works out. So we deeply appreciate everyone for joining us. Thank you, and we will see you soon. Thanks.